Swami Dan Swami Dayanand Saraswati was born on 12th February 1824 in Tankara, Gujarat, in Brahmin family. His parents, Lalji Tiwari and Yashodabai, were Orthodox Brahmin, and his earlier name was Mool Shankar Tiwari. He was born during Mool Nakshatra. He wandered as an atheistic for 15 years, 1845 to 60, in search for truth. The contribution of the society. He was an Indian philosopher and social leader and founder of the Arya Samaj. Arya Samaj is the reform movement of the Vedic Dharma, and he was the first to give the call for Swaraj and India for the Indians in 1876. He was a self-taught man and a great leader of Indian, leaving a significant impact on Indian society during his life. He made a prominent name for himself, and he was known among the wide arrays of prices and the public. And his contribution to the education system, he introduced a complete and overhaul the education system. He is often considered as one of the visionaries of modern India. The DAB means Dayanand Anglo-Vedic School came into existence in 1886 to realize the vision of Swami Dayanand Saraswati. As teacher, now I would like to give a small introduction of esteemed resource person, Dr. Debasish Biswas. Debasish Biswas is presently serving as the assistant professor in the Department of Business Administration, Vidyasagar University, West Bengal. He was awarded MPhil in Commerce from Periyar University in 2008 and PhD degree in Commerce on 7 September 2011 by University of North Bengal. His research was productivity and industrial relations. Dr. Biswas obtained MCom in 2000 and MBA HR in 2002 from Bardhaman University. He is having a postgraduate teaching experience and more than 12 years. He was presented 19 research papers in different areas of management and different national and international seminar conferences. He was the author 76 papers and national and international journals of reputed. He acted as a resource person in different national and international seminar in different parts of India. He was authored a 23 books title. He received Best Business Academic of the Award 2016 Gold Medal at the 16th All India Commerce Conference organized by Lucknow University. He received Bharat Vikas Award in 2018 by the Institute of Self-Reliance, Odisha. Dr. Biswas developed a study material of MBA courses of distance education wing of Tezpur Central University in Assam. He was successfully guided 10 PhD scholars, and he was been invited as a resource person in various corporate training programs. Now, I would like to Dr. Debasish sir, please hand over the session and give the light on the research methodology part.
Thank you very much, Pran Gopal.
Thank you, sir.
I again welcome you, sir, for the session. And today he will be delivering a very interesting topic, which is used in different social researches. That is the factor analysis, which is very popular. So we are having we will be waiting to see your deliberation as far as this factor analysis is concerned, since it's important to different social aspects and social researches, sir. So I will welcome you again in this FDP in this session.
Thank you. Thank you very much, Dr. Deep Jyoti Chaudhary. And it is my immense pleasure to interact with the participants, almost all parts of our country. And it is a very good initiative taken by Assam University, which is a central university, in collaborations with our Vidyasagar University. At the very outset, I convey my deep sense of gratitude to the Vice Chancellor of Assam University Central, as well as to our Vice Chancellor, that is from Vidyasagar University. I convey my deep sense of gratitude to the organizers as well as the coordinators of this interactive session. And I will be delivering on factor analysis. So before starting the factor analysis, I will give you some conceptions so that when we'll be dealing with the factor analysis, you will not face any problem. So some clarifications are to be required at first, and so that it will be very easier for you to understand when factor analysis will be get from factor analysis technique. The first thing is, when we are thinking about so many variables in our research, then our entire research work will be a question, because all variables having some distinct characteristics, and on the basis of all the variables, if any organization is going to make any strategy, then it will not be the strongest strategy, because the number of variables are numerous. So we will face one kind of problem in that case. 1 second, please. Yes. So the main objectives of factor analysis has to be understood at first. Why factor analysis is required, and in which situation factor analysis will be used in our research methodology. That has to be cleared at first. And when we are dealing with factor analysis, we have particularly two objectives that has to be kept into your mind. We have two main objectives behind factor analysis, or behind the applications of factor analysis. And what are those two objectives? The first objective is data reduction. It is a data reduction technique. Just I'm giving you one example. Suppose, being a researcher, we are dealing with 40 variables. So it is very difficult to manage all these 40 variables at a time. So if we can reduce from 40 variables to suppose 20 variables or 25 variables, then it will be very easier for us to manage, or it will be easier for the organization to make their strategy accordingly. So the first objective is data reduction. So factor analysis, it is a data reduction technique, so that we can reduce number of variables. If there is a large number of variables, then it is not manageable for us. In that case, we have to reduce the huge number of variables into a some manageable variables. That is the first objective. That is the data reduction. You may also note down why factor analysis is done. One is data reduction. So it is a data reduction technique. Now the question is how the variables will be reduced. Suppose we are dealing with 40 variables and we are making it 25. How? So obviously there must be certain filtering process. Research is nothing but a filtering process. It is not like that we are taking 40 variables or 50 variables, and at the end of our research work, 50 variables will remain present. No. So that is called the filtering process. So when the filtering process will be done, it will be exclusively on the basis of the correlation coefficient. So correlation coefficient will take a very important role in this filtering process, through which maximum number of variables will be converted into manageable number of variables. So the filtering process should be done, and the filtering will be done on the basis of simple correlation coefficient technique or simple correlation coefficient matrix. That is the first thing, the how data reduction will be done. And the second objective behind factor analysis is data summarization. So one is data reduction, another one is data summarization. So summarization is nothing but the condensed form. Suppose in the first case, through data reduction technique, initially we took 40 variables, but after filtering, it has come to now 25 variables, suppose. Now, under data summarization, these 25 variables will be clubbed into certain distinct factors on the basis of the similarity among the variables. Again, I am trying to say, suppose after the data reduction, we have got 25 variables. Now, out of these 25 variables, again, it is very difficult to manage these 25 variables. So what we are trying to do, these 25 variables will be clubbed into certain distinct factors on the basis of the intercorrelations among the variables. Suppose out of these 25 variables, 6 variables are interrelated with each other. So these 6 variables will be clubbed into a distinct factor. So 25 minus 6. Now we have 19 variables. So out of these 19 variables, suppose 5 variables will be clubbed under another factor. In this way, suppose we have got 5 factors. So then it will be again very easier to manage this 5 factor rather than managing the 25 variables. So now I am just giving you the summary, what I have told you. So first is, initially we took 40 variables. After data reduction, we have got 25. Then after the summarization process, then finally we have got 5 distinct factors. So if any company asks you, what would be our strategy? Suppose what would be our strategy in case of pricing, in case of marketing the products, in case of the advertising strategy? Then if you give them answer, yes, sir, you consider 25 variables, then they will not accept. But if you say them, sir, only 5 factors are required, and you have to emphasize on these 5 factors and show that you can build a very concrete strategy, so everyone will accept it. So factor analysis, that's why it is a very, very popular technique. But whatever the discussions I will do with you today, that is only restricted to a particular type of factor analysis. Because within this 2-hour session, it is not possible to cover the entire domain of factor analysis. It is so vast. So from this today's session, you will get some idea about exploratory factor analysis. I will only emphasize on exploratory factor analysis. Why I am discussing it? Because you know that in our social science research, basically, there are three types of research or research design. One is called descriptive research. Another one is called causal research, where we established the cause and effect relations. And third type of research design or research type in our social science is exploratory research. So if you want to explore certain undiscovered areas in the field of marketing, in the field of HR, or in any field in our management, then we can apply exploratory factor analysis technique. So if you know the exploratory factor analysis technique, then you can conduct any type of exploratory research work easily. But you have to know the technique in a very scientific way so that you will not face any problem. Because in our social science, so many controversies are there, because it is not just like a pure science. It is not lab-based experiment. So the result will vary. Therefore, when we are mentioning any result, sufficient citations are needed. Otherwise, you cannot publish good quality of research work in very prestigious journals. So one by one, I will clear all these things. So now I hope you have understood what are the objectives of exploratory factor analysis. So one is data reduction, and the second one is
summarizing
or data summarization. Very good. So first I will show you how data reduction is done, and subsequently I will show you how the data summarization is done. If you know these two things, then I hope you can easily conduct exploratory type of research. So I will start with a case study. And before going to the case study, another thing I want to share with you. Always keep in your mind, factor means combinations of certain variables. So what is the difference? Factor consists of more than one variables. And which variables will be taken into consideration into a particular factor if these variables are interrelated with one another. Otherwise, they will not form a particular factor. So that is the difference between variable and factor. In some books, it is written construct. So factor and construct, both are same things. There is no difference. In some books, some authors, they mention as construct. Some books, factor. So basically, it is a factor or construct. Another thing is that in the domain of factor analysis technique, mainly we deal with two types of technique that you have to understand at first. One is called independent technique or interdependence technique, and another one is called dependence technique. So today's discussions will be restricted to interdependence technique. I will not discuss anything about dependence technique. So where is the difference? In the first case, all the variables that we are taking into consideration are basically independent in nature. This is our assumption. Independent in nature. But when we'll make any study about dependence technique, in that case, both dependent as well as independent variables are to be taken into consideration. So that's why factor analysis is divided into two parts. One is simply exploratory factor analysis, which is interdependence technique, only we are considering independent variables. But in case of dependence technique, that is called the confirmatory factor analysis as well as structural equation modeling. When we are talking about structural equation modeling, it is a dependence technique. We are trying to maintain some relations between dependent and independent construct or factor, either construct or factor. Both are synonymous. But when we are saying we are doing exploratory factor analysis, we are considering only the independent variables. And these independent variables are forming certain factors. And whether these factors, whatever we have explored, whether these factors are basically genuine factors or whatever the variables have been clubbed into a particular factor that is reliable or not, that's why confirmatory factor analysis is conducted. So mainly there are three stages. One is exploratory factor analysis, to explore the factors, and whatever the factors have been explored, that has to be confirmed through confirmatory factor analysis. In some books it is known as the measurement model. But when we are dealing with dependence technique between independent and dependent construct, then we have to run structural equation modeling. So for exploratory factor analysis, generally we use SPSS technique or SPSS software. For running or for conducting exploratory factor analysis, basically we use very popular software. You also know it, SPSS, Statistical Package for Social Science. And for measurement model or for confirmatory factor analysis, various softwares are available in the market. But very old software is AMOS, Analysis of Moment Structure, or AMOS. AMOS software is used for confirmatory factor analysis, or you can say for measurement model. We are measuring whether the factors are genuine or not, whether the variables under a factor is reliable or not, that we have to check. That's why it is called the confirmatory factor analysis, or in some books it is known as the measurement model. And for conducting structural equation modeling, we can also use AMOS software. But apart from AMOS, nowadays many researchers, they are using smart PLS technique, or some researchers, they are also using another very sophisticated software, and it is basically our department has also brought from Germany. The name of this software is Adanko software. It is a very, very sophisticated software. But the disadvantage is that if you apply the Adanko software, you will get all the results at a time. But how these results have come, that we have to understand. So my particular suggestion, my personal suggestion for the beginners, who are the beginners, they must go for AMOS software for structural equation modeling as well as the confirmatory factor analysis. And for exploratory factor analysis, you use SPSS software. So many softwares are there. I am not suggesting any particular software, or I'm not talking about any from any particular company, right? So I am only discussing from the researcher's point of view, which is more convenient to us because we are experienced. We have nurtured so many softwares, and from that experience, I'm sharing this. So another thing, before going to the practical session, all these theoretical concepts are to be cleared. Another thing, what type of data is required for factor analysis? So many researchers are facing this type of problem. What types of data are required? That means, particularly, what would be your measurement scale? Because when you are collecting some data, you have to apply certain measurement scale. You know that. One scale is nominal scale. The second one is ordinal scale. That is the Likert 5-point or 7-point. All these scales are ordinal scale. And another type of scale is interval scale and ratio scale. So if you want to conduct the factor analysis, then basically the ratio data or ratio measurement scale or interval measurement scale, these are the appropriate technique. But nowadays, when I adjudicate some thesis by the researcher, then I find that many researchers, they have used ordinal scale, like at 5-point or 7-point ordinal scale, and they are also running the factor analysis. But if you want the scientific method, if you want to know the scientific method, when the factor analysis, what types of data are suitable for factor analysis, then it is basically suitable for ratio or interval data. That means in case of, if your data is metric in nature, in a very precise way, we can say that if the nature of your data is metric, in that case, factor analysis is suitable. So, in a nutshell, what we can say, what is factor analysis? What are the objectives of factor analysis? What are the differences between factor and variable? And factor and construct both are synonymous. What types of data are required? Now I will share another one point that you will also keep note. When you are running factor analysis, then it is a thumb rule. It is a thumb rule. If you want to get a very good result, then in that case, many authors have suggested it. I am also suggesting it. For one question, keep in your mind, for one question, that means one question means one variable. Question is nothing but a variable, because we are trying to collect the data through a structured questionnaire. Suppose one questionnaire consists of 20 questions. That means in our study, we are dealing with 20 variables. We are dealing with 20 variables. So the suggestion is, for one question, the number of respondents, it must be minimum 10. If it is 15, it is very good. 20, it is very good, extremely good. You will get very good result. So for one question, at least keep in your mind, 10 respondents will be required. Suppose in your study, you are doing your research, taking 20 questions. That means 20 variables. That means 20 into 10. This is the thumb rule. The sample size, minimum sample size, it must be 20 into 10, that is 200. Or per questions, you are taking 15 respondents. So in that case, 300. But if you want to get some robust result, in that case, the ratio should be maintained 1:20. For one question, you have to take 20 respondents. So 20 questions, the total sample size will be 400. In this way, the factor analysis.
Sir, excuse me, sir. Sir, here you are telling about that question, no, sir. That question indicates variable or one item, sir. Because for measuring a variable, we may take 5 items, 6 items, 7 items also. Here the question indicates a variable or a single item, sir. It means a single question is single item, is it, sir?
Okay, I am explaining. It is better if you ask the questions after the session, right? So
okay, sir. Okay, sir. You can
no. I will clarify you. Whether you have asked me, I will clarify you. One thing, madam. One question means one variable, and one variable means one item. One item means one indicator. There are no differences. Is it clear to you?
Sir, like one variable will be measured by many items, no, sir?
One
There may be
variable
3
means,
items.
suppose age is one variable.
Okay, sir, you are talking about demographic variable. In that case, there will be only one item, sir.
Suppose age is, I am not classifying any variable. Suppose age is one variable.
Okay.
So what is your age? I will ask you one question.
Okay. Sir, like in case of, for example, if I'm taking customer satisfaction.
Customer satisfaction, it is not a variable. Customer satisfaction is a dimension.
Okay.
Under customer satisfaction, if you say, are you satisfied? Is it the questionnaire of customer satisfaction?
No, sir.
Yes, yes. Now you are right. So customer
Okay.
satisfaction, it might be one dimension, or it might be one factor, or it might be one construct, and which consists of some variables, some questions, so that we can have a clear idea about the customer satisfaction.
Okay, sir. Yeah.
But your question is very good. But I hope after my interaction, after my session, everything I will clear you, right?
Okay,
And I
sir.
will
Okay,
take
sir.
sufficient questions.
Thank you, sir.
problem,
Thank you very
problem.
much, sir.
Okay, okay. So all these are the theoretical concepts. Now I will go to the practical aspect. It will be very, very interesting. You will enjoy a lot. Because now the theoretical foundation is clear. So is there any other question? You please ask me. And after that, I will go to the practical session.
Sir, for once, can you just repeat which one was the independence technique and which one was the dependence technique?
Very good question. Very good question. So in case of interdependence, independence, interdependence, right? In case of interdependence technique, we only consider all the independent variables. But when we are doing structural equation modeling, then we try to make a relation among various factors or among various constructs. Suppose just I'm giving you one example. I'm giving you one example. Suppose attitude, subjective norms, perceived behavior control. All these three things are three different constructs, three different factors. Now, if your study is only restricted with these three independent factors, then it is an interdependence technique. But when you are saying these three factors, I want to correlate with another factor which is dependent in nature, suppose that is purchase intention. So what I'm trying to say, attitude, subjective norms, perceived behavior control, these independent construct affecting purchase intention. And again, I'm trying to show purchase intention affecting purchase behavior. So what I'm trying to do? Basically, dependence technique, because here some constructs are dependent in nature. Purchase intention, it depends upon attitude, subjective norms, and perceived behavior control. On the other hand, purchase behavior, it depends on purchase intention. So purchase intention and purchase behavior, these are dependent construct. And perceived behavioral control, subjective norms, and attitude, these are independent construct. An independent construct or independent factor in our factor analysis, these are called exogenous construct. And the dependent construct is called endogenous construct. So when we are trying to connect exogenous construct to endogenous construct, then that is the examples of structural equation modeling. Understood my point, madam?
Yes, sir. Yes, sir. Thank you, sir.
Okay, welcome. Now I will start with a case study. And first you will understand the case study. I will take just 5 minutes time to understand the case study. And after that, we will show you how the data reduction is done using SPSS software. So I'm just sharing my screen. Basically, I am very comfortable with Google Meet. Here only the option is share screen, right? Anyone?
Yes, sir.
Only share screen.
You share, then you choose desktop.
Okay, okay. Share screen. Yes. Share screen, then I will select screen.
Desktop.
Desktop.
Oh, it's there na desktop.
No.
First click on share screen, sir.
Share screen.
Yes. Then go to desktop.
Then go to desktop, but
Dex-
desktop option is not showing. Screen option is showing.
Screen.
Okay, sir. Click screen then.
Yes.
Yeah, it is coming.
My screen is visible to you.
Yeah, visible, visible.
Yes,
Okay,
sir,
okay, okay,
visible.
okay.
Click. Yes, sir. Yes, click on it.
Okay. Right.
Case study is there. Click on
Yes.
case study.
Yes. Now I understand. Yes.
Click on maximize, sir. On
Click
top.
on maximize.
Yes. Click on it.
Grid video. Then show small active speaker video.
So it says what file, PDF file or what file, sir?
It is PDF file.
Just click on, sir, maximize, sir.
Okay.
On top bottom, not this side, sir.
Oh.
On top, sir. Right corner.
On right corner. Here.
Not this, sir. On page.
On page.
The
Page.
window that you open, sir, PDF window, there is again maximize option. And at the top, sir, at the top.
Top right corner.
The top, further top.
Further top.
The square box beside the cross.
Beside the
one cross is there on right
Huh?
corner. Further top, sir. On the further top.
On the further top. Yes.
Sir, you have a symbol of a person, man, in black color. If you see in the PDF. Above that, right side, right above that, above, further above. Yeah, further above.
Sir, it is top right corner.
Just top of that, sir. Where
The
your
top
cursor
of-
is located. Not this one.
Not this one.
Not this one. Another same type of thing is there in the PDF.
So there is the title case study PDF. You can see at the top. Case study PDF.
Case study PDF. Yes.
Yes,
Above
you
that,
can see
sir,
now.
top,
Just
top,
double click it.
Okay.
On the case study PDF, just double click it.
Okay. But it is not
At the above, sir. At the above, the title.
Sir, within the document
within the.
that you have opened,
Yes.
on the top rim, sir, go on the top rim of,
Top.
and come to the right corner.
Here.
Same place. Sir. Come further. More. Yeah. Come to the right side, sir. Right side.
Your right side.
Extreme right, sir.
Yes. More.
Further. You go further ahead.
Further.
Yeah.
Towards the right.
On
you
the
have
same rim, you come to the right side.
Sir, can you see where it is written Foxit Reader?
The four boxes of this Microsoft you can see. You are at
Name
the
of the document, PDF
name of the title of the document where you were, sir. You go to the top rim of that. More, further up. Oh, more and more. Some
Here?
more. Some more. On
More.
the top line you go. On the top
Yes,
line.
top line. This is the top line.
No, sir. Further
Yeah.
top is there above that.
Further top.
Above that, yeah. Where the title is written.
Case study.pdf is there,
Yeah.
no, sir?
Yeah. Case
One
study.
second, I'm
PDF.
trying. I'm trying this.
Right now, so can you see a box, sir, beside cross at the top?
Minimize button, maximize button is there.
Sir, you do one thing. I am telling, yeah, you drag that. There is plus sign, and in the side is three lines is there. Just check. Slanting.
3 lines.
You
3
drag
lines.
it by that. You drag it by that. Yeah, you drag it.
Yes. Thank you. Now is it visible?
Yes, sir.
Okay. So this is a case study of national company. It is a book publishing company. And the primary database consisting of 120 observations on 20 questions. That means here the ratio is 1:10. 20 questions, 26, 1:6 is based on a market segmentation study on national customers. And the information view perceptions of nationals performance on 15 attributes. That means out of 20 questions, our scale question is 15 attributes we have taken into consideration. And respondents of educational institutes and the booksellers buying from national, and they rated national on each of the 15 questions using 0 to 10 scale, with 10 being excellent and 0 being poor. So we have used 0 to 10 point scale, and these are the questions. I'm not going through all these questions. The question number 1, so one question implies one variable. In this way, we have considered 15 variables, and some variables are categorical, but we will consider only these 15 variables. So out of these 15 variables, how the total number of variables will be reduced, that is called the data reduction. And how it will be done on the basis of correlation coefficient matrix. So this is our case study. Next is yes. I am just opening my data file. Yes. Yes, it is opening. It takes a little bit time. Yes, it is coming. Yes. Now you know how to put the data, and this is my variable view. And we have put it all these 20 questions. But in our exploratory study, we will only consider the scale variable. These are the symbol of scale. So up to 15 questions. These are basically scale variable, and these are the nominal. So we'll not consider the nominal variable in our study. We'll only consider the scale variable. So now I am going to data view. Yes, these are my data view. And we have considered 120 respondents and using 1 to 10 point rating scale. And so many respondents have given their own opinions. So this is our data file. So we are considering 15 number of variables. The first is how this 15 number of variables will be reduced using correlation coefficient technique. Why I am saying this? Why for the filtering process we are using correlation coefficient technique? The reason is, or the answer is, if some of the variables are not being moderately correlated, they will not form any factor. So the existence of correlation coefficient among the variables must be there. Otherwise, we cannot make any factor on the basis of the commonalities among the variables. So that's why correlation coefficient technique is used for this filtering process. Now you will listen very minutely. So these are my 15 variables. Just I'm going to, 1 second. Yes, this is my analysis. Go to analysis. Go to analysis. So nothing to be written, right? I will give you the entire PPT so that you can easily go through this command. No need to write any command. Just you listen. First is analyze. Then for factor analysis, our objective is dimension reduction. So I'm selecting dimension reduction. Then I'm coming to this option factor, but I'm not doing factor analysis. First, I'm doing data reduction with the help of simple correlation coefficient technique. Go to factor. Now I am considering 15 variables one by one. Just pressing my control button. I have taken 15 variables to this variable box. So the command is analyze, then dimension reduction, then factor. Then I have taken all these 15 variables to the variables box for analysis purpose. Now I am selecting descriptive option, only descriptive option. Our objective is determine the correlation coefficient. So click on this option coefficient and click on determinant. So only two options, coefficients as well as the determinant. Then continue. Then OK. Now what we are observing, correlation matrix have been formed. 1, 2, 3, 4 in this way, 15 questions are there. And along the column, 15 questions are also there. And these are the correlation coefficient matrix that have been formed. 15 into 15. Now, out of these 15 variables, which variables are to be removed from our study? That is called the first filtering. We have to take a decision whether we will consider all these 15 variables or some variables will be removed from our study. that will be done on the basis of the correlation coefficient. So that's why we are copying this table. We are copying this table. Just copy it. Then paste it. Then paste it into any Excel file. Paste it into any Excel file. One thing, it has to be closed. Okay. One second. All these things have come.
The top right corner has the close button, sir.
I want to go my screen, right? Mhm.
Sir, first click on right corner of your top button, sir. Top line, sir, above top line.
Above top line. Above top line, only 3 dot points.
Sir,
Cross
on
mark
the-
is there now, sir. Cross mark.
start.
So you
from
just
zip.
simply press
Yes,
window and D.
Yes.
Yeah, window and D. Okay.
Okay.
That's fine, sir.
Thank you. So I'm just opening my Excel file. Yes. Now I am just pasting the correlation coefficients matrix. Yes. Yes. This is my correlation coefficients matrix. 15 into 15. Now we have to select only the data, not these things, only the data. One second. Yes. We have selected only the numeric data. Yes. Now we will go to this option in our Excel, that is conditional formatting. That is the conditional formatting. Click here. Then go to new rule. Then select the first option, format only cells that contain. Now look at this. Format only cells, you have to give a specific range of the correlation coefficient. And I have already told you, in case of factor analysis, a moderate correlation is required. Not very low, moderate correlation is required. So it is our thumb rule. We can specify the range minus 0.52 minus 0.52 plus 0.5 minus 0.52 plus 0.5. This is comma or full stop? Point. Okay. So we have to give a specific range minus 0.5 to plus 0.5. Then go to format. Then go to format. Go to format. Then go to fill option. Select any color. It depends upon your choice. So I am selecting this color. Then OK. Then again OK. Now look at this matrix. Now look at this matrix. How we'll check which variable will be removed? How we will check? We will check column wise. The first column means first variable. That is the question number 1. 2, 3, 4 in this way up to question number 15 are there. Now when we are checking the first column, that is for question number 1. That is for question number 1. One value is greater than 0.5, that is 0.780. So we cannot remove this question or we cannot remove this variable from our study. Now look at this column, that is for question number 2. There is no value which is greater than 0.5. Right? There is no value. This is the value between question number 2 and question number 2. That's why it is 1. We are not considering it. And here, suppose question number 1 and question number 1. So obviously it will be 1. But here one high value is there. So we cannot remove the question number 1. But we will delete the question number 2 because there is no sufficient strong correlation or moderate correlation which is greater than 0.5. So when we'll run the factor analysis, we will not consider question number 2 or variable number 2. Now we are coming to column 3. What is happening in column 3? Same thing. There is no value. There is no value which is higher than 0.5. So question number 3 will not be taken into consideration. Then 4, yes, value is there. Question number 5, value is there, greater than 0.5. Question number 6, value is there. Question number 7, value is there. Question number 8, no value is there. So question number 8 will be removed. Question number 8, that means 8 variable will be removed from our study, from our further study. Then 10, question number 8, question number 9, value is there. Question number 10, value is there. Question number 11, yes, value is there. Question number 12, value is there. Question number 13, no value, no strong value. So 13 will be deleted. Question number 14, no value, no strong value. So 14 will be deleted. Question number 15, yes, value was there. So finally, on the basis of the correlation coefficient matrix, we have taken the decision when we'll run the factor analysis after this step. Then under that factor analysis technique, question number 2, question number 3, question number 8, question number 13, and question number 14 will be deleted. So initially we started our analysis with 15 variables, that is 15 questions. But after the filtration process on the basis of the correlation coefficient, 5 variables will be removed from our study. So now we will be dealing with 10 variables, not 15 variables. That's why it is called data reduction technique. Here the data reduction means variable reduction. Data reduction technique. Now, finally, we'll consider question number 1, 4, 5, 6, 7. We'll not consider 8, then 9, 10, 11, 12, and 15. Finally, we will consider these 10 questions for factor analysis. So I am closing this Excel file. Yes. Now I'm coming to the data set. Yes, this is my data set. Now, the second step, that is the data summarization, where we will be able to explore the factor. So now the second stage or second step, analyze dimension reduction factor. Click here. Then will not consider question number 2. So we are removing question number 2 from here by clicking this icon. Question number 3 will be also removed. We are removing. Then question number 8. Then another 2 variables. Question number 13. Then question number 14. So we are now do our analysis with these 10 variables. Why we are considering these 10 variables? Because on the basis of the correlation coefficient, we are sure among these variables, moderate correlations are there, at least greater than 0.5. Moderate correlations are there. Therefore, our variables are ready to form or to club under certain factors. So, after the filtration process, some variables have been removed from our study. So, when you will write your report, then obviously you have to discuss about your filtration process and whatever the specific coefficients of correlation range you assigned over there, and on the basis of that correlation coefficient, which variables you are removing from your study, that you have to mention. And finally, we are running your factor analysis after taking these 10 variables. Now there are 5 options under factor analysis. These are 5 options. So one by one, I will show you. So the first is obviously the descriptive. This option first is descriptive. Now under descriptive, one thing is very, very important to run the factor analysis. That is, we have to check the value of KMO and Bartlett's test of sphericity. And I will explain what is KMO and what is Bartlett's test of sphericity. So when you are conducting your factor analysis, then you have to check the KMO result and Bartlett's test result. KMO result and Bartlett's test result. But in the first stage, only correlation coefficient was considered. because our intention was not to conduct the factor analysis. First, we did the filtering for removing some variables where the minimum correlations are present, very low correlations are present. But second stage, as we are going to conduct the factor analysis, therefore KMO and Bartlett's test of sphericity, these are to be checked. So I'm clicking on this option, KMO and Bartlett's test of sphericity. Then continue. Second is extraction. Now under extraction, there are various methods to conduct the factor analysis, but in most of the cases, we select the method that is the principal component. And again, I am trying to say one thing. Here the principal component means the analysis will explore the very important component at first. Here the component means important factor at first. Suppose after the factor analysis, suppose we will be getting three factors, factor 1, factor 2 and factor 3, suppose. So we can easily say that factor 1 is more important than factor 2 and factor 2 is more important than factor 3. So there are various methods, but my suggestion is you select principal component method for factor analysis. Extraction, that means to explore the factor, we will use the common technique, that is the principal component analysis. So it is already principal component analysis. Now you can also give a click to that scree plot, and what is scree plot I will explain. Then continue. Another thing, there is one option, fixed number of factors. That means you can also fix how many factors you want to get, but my suggestion is do not do that. You let them on the analysis, that is the principal component analysis method. So software will generate it. Don't fix the number of factors. So now continue. Next is the rotation. This is another thing. There are so many methods under rotation technique. Rotation means where the variables will be distributed properly. That's why rotation method is used. And very popular method is Varimax method. And if you apply Varimax method, then your all the variables will be arranged in such a way so they will be formed certain factors. So here the selection option is Varimax option. Then continue. You can check with also other options, obviously. So if you practice more and more, you will learn more. So Varimax you select, then continue. Then the fourth is code. So obviously whatever the results will be explored, that has to be saved. So save as variable, as well as display. If you want to show the factor score coefficient matrix, then you click here also. Then continue. Then go to option. Now you click here sorted by size, so that you do not need to arrange the variables on the basis of the size. Automatically it will be arranged on the basis of the size. Size means here the factor loadings. So sorted by size. And another option is suppress small coefficient. If any coefficient value is very small, then again it will create a problem. So that's why you may also assign here a moderate value. You may give 0.5 or 0.6, anything you give, but not less than 0.5, right? So in the first filtering, Our range was 0.5 minus 0.5 to plus 0.5. And here you can also give 0.5, or if you want to avoid any kind of cross-loading situation, you may increase the value, that is the 0.60 or above. So the value less than 0.60 will not be shown, right? So then continue. So again, I am repeating, under descriptives, you click on KMO and Bartlett's test of sphericity. Under extraction, you will click on principal component as well as the scree plot. Under rotation, popular method is Varimax. Under score, you have to save as variables as well as you have to display factor score coefficient matrix. Under option,
2 steps. Can you go 2 steps earlier?
Second step, madam.
After extraction.
After extraction. One second. After extraction, then rotation. Only you click on Varimax, right? Only you will click on Varimax.
Yes.
Other methods are also there. But if you apply the Varimax, then all the variables will be distributed in such a way so that you can explore more than one factor. Otherwise, sometimes what happens, suppose all the variables are clubbing under first factor. So this is not very good. Clear? So for proper distributions of variables, so that we can get more than one factors, our preferable option is Varimax option. So continue. So I have already shown scores. Continue. Then options. Here minimum value is 0.5. You may also give 0.60 or 0.70, anything, whatever you want. Then continue. Now, okay. Now, one by one, I will explain. You may also note down certain points if you feel. So first, I will not talk anything because it is only the correlation matrix that I have already shown you how the correlation matrix is helpful for us for the filtering. So here, no filtering is possible. Here only the correlation matrix have been formed because we have given that option. So here we have got 10 into 10 correlation matrix. So I'll not saying anything on this issue. The second very, very important issue, that is to check the value of KMO and Bartlett's test. There are two objectives. Why we have to check this value? Otherwise, your factor analysis result will not be accepted. And here the thumb rule. First, I am saying the thumb rule. The KMO value, the minimum value of KMO, if the value is large, greater than 0.50, it is very good. But the minimum acceptable value, that must be 0.50. Otherwise, you cannot do factor analysis. So what is the implications of this test? Now, here the implication is already mentioned. What is written here? Whether my sample size is adequate or not. If the KMO value is less than 0.50, that means my sample size, whatever the sample size we have taken, in our study we have taken suppose 120. So this sample size is not enough to run the factor analysis because sample is not adequate. But if the KMO value, if it is greater than 0.50, it implies that sample is adequate to our study. You know that there are various techniques that generally we use for determining the sample size. That obviously you know. Rao-Soft formula is there, Cochrane formula is there. But in case of factor analysis, that formula will not be applicable. Only the checking criteria is the value of the KMO. So if the KMO value is 0.50 or more, then our sample size is our sample size is adequate. So our sample size is adequate. And the second result, most of the researchers, they do not report this. That is the Bartlett's test of sphericity, what it implies. I have already told you that if we want to conduct a factor analysis among some variables, then the variables must be correlated with one another. If there is no correlation, so no factor can be explored. So here, the null hypothesis in this case, the null hypothesis is there is no correlation among the variables. That is our null hypothesis. And what is the probability value? The probability value is significant. That is less than 0.50. Therefore, our null hypothesis is rejected and alternate hypothesis is accepted. And alternate hypothesis is accepted, it implies that there are some sort of correlation among some of the variables, right? Some of the variables, somehow they are correlated with one another. That's why Bartlett's test of sphericity result, that must be significant. So we have to check the probability value. So if probability is significant, that means the null hypothesis is rejected and alternate hypothesis is accepted. So alternate hypothesis is accepted. So there are certain sort of correlation among the variables. Next reporting point, that is the communalities. Very, very important things in our factor analysis. One is the communalities, another is called eigenvalue. That I am coming later on. So first I have to make you clear what is the communalities. So you will report the value of the communality, that is the right-hand value, that is the extraction. Now what we are observing, we have 10 communalities, values of 10 communalities. That means for each variable, communality is shown. For each variable, communality is shown. As we have considered 10 variables, so 10 results are shown here. And all these results, keep in your mind, you will note down it. All these results, at least, it must be greater than 0.50. At least, minimum value must be 0.50. Suppose one value of the communality is less than 0.50 after running the factor analysis, then what will do? Then again the filtering will be done. That variable will be removed and again we'll run the factor analysis. Then we'll get the robust result. So again I am saying the research is nothing but the filtration process. More you filter, you will get the refined result. The robustness will be there. So in case of the communality, what it implies, basically this is the, you may also note down, this is the proportion, this is the proportion, this is the fraction of each variable. The proportion of each variable. What? Each variable's variance, that is explained by various factors. So various factors, we do not know how many factors have been explored, but we can say that with the help of these factors, we can explain 75.5% variance of first variable. That is the question number 1. So again, I am repeating. So communalities, this is the proportion of each variable's variance, that can be explained by the factors or by the construct. That is called the communalities. And here the communalities of each variable, it must be at least, it must be 0.50. And if it is more than 0.50, that is very good. Next is, this is the central theme of our exploratory factor analysis. This is the main table that we have got. So the first is eigenvalue. The first is eigenvalue. So on the introspection of the eigenvalue, on the introspection of the eigenvalue, we can easily say that how many factors have been basically considered. So the thumb rule is, if the eigenvalue of any factor, here the component means factor, eigenvalue of any factor, if it exceeds 1, again I am repeating, because this is a very, very important thing, the value or the eigenvalue of each component, it must be greater than 1. So first factor, that is the 4.108. So I have already told you, it is a common sense just to apply it. The first factor, it is more important than the second factor. Second factor is more important than the third factor. Second factor is more important than the third factor. Why? Because we have applied principal component. That means whatever the component is most important, that will be placed at the first position through this software. So what is the implication of the eigenvalue? I have already explained what is the implication of commonalities, but where is the difference? What is the implications of the eigenvalue? Eigenvalue, it basically implies, you may note down, eigenvalue basically implies the explanatory power of a particular factor. Explanatory power of a particular factor. Explanatory power. Explanatory power of a particular factor. So in this case, the first component, the eigenvalue is 4.108, and if you see the result of the variance, percentage of variance, then 33.59% variance. 33.59, that means near about 34% variance is being properly explained by the first component. That means by the first factor. Next factor or next component, what is the eigenvalue? 2.128. That is a more than 1. So again, what we are noticing? Yes, this second component, that means the second factor consisting of certain variables, it is able to explain 24.521% of variance. So in total, these two factors combined together, they are explaining 33.59 by the first factor and by the second factor 24.521, and if you add this, then this is the cumulative percentage, that is the 58.117. Now another factor, that is the third component, having the eigenvalue that is the greater than 1. Eigenvalue is greater than 1. So this factor is also contributing, but it is little bit lesser than the second component or second factor. So the third component, it is able to explain 20.188. So in our factor analysis, what we are observing, 3 factors have been explored. 3 factors have been explored, and we consider finally 10 variables. Initially we took 15 variables, then it has come down to 10 variables. Now we run the factor analysis. Now on the basis of the eigenvalue, what we are observing, 3 factors have been explored, and with the help of these 3 factors, we can explain 78.306% of variance. That is the explanatory power of our 3 factors. So explanatory power, eigenvalue, actually it implies the explanatory power of a particular factor. Explanatory power of the particular factor. That is called the eigenvalue. So thumb rule is that, now thumb rule is that if total variance up to 60%, up to 60, in our social science, up to 60%, if this value is 0.60, so it is okay. But here it is 78. That is a very good. So up to 60%. So again, I am repeating this in a nutshell.
So I have a doubt.
Yes.
Sir, I did not understand what happens when the value exceeds, eigenvalue exceeds more than 1.
Again, I am saying eigenvalue exceeds 1 means the explanatory power of your construct is sufficient. Clear? So how to calculate, the manual calculation is there, how the eigenvalue is coming, but the interpretation, I am just explaining the interpretation part. The eigenvalue, if it is greater than 1, that means this variable is basically sufficient to explain the variance of certain variables. Clear? Of certain variables. So how this value is coming, that I am not discussing the mathematical part, but the interpretation part is, if it is greater than 1, that means this factor you cannot ignore, because it has some sort of explanatory power and which can explain the variance of certain variables which have been clubbed under the first factor, similarly under the second factor, under the third factor, right? So in total, the total explanation is 78.306%. Next, another thing is the scree plot. So from this scree plot, it is not necessary, but we may also show this result. So component number and another side the eigenvalue. So on the, I have already told you, on the basis of the eigenvalue, the factors will be formed. So it is clearly shown this to this, one factor, this to this, another factor, this to this, another factor. And after that, the contribution of the factors are little bit very less. Clear? So we have here inspected 3 distinct component or 3 distinct factor. One is this is one factor, and this is another factor, and this is another factor. So on the basis of this eigenvalue, suppose it is a 4.108, so this point is a 4.108, and after that 2.128, then 1.594. So there are 3 cutoff points. So this to this first factor, this to this second factor, and this to this third factor. Now another important thing, which variables are coming under which factor? That is also the fundamental questions. That questions will be answered not from the component matrix. Remember this. It will be answered from the result of rotated component matrix. Rotated component matrix, not this matrix. So I am coming to the rotated component matrix. Now what you are observing? Question number 4, question number 11, question number 6, question number 10, question number 15, all these 5 variables constitute the first component or first factor, and where the explanatory part is 30, near about 33 point, that is near about 34%. But another thing, you notice it. If suppose using the first factor, your explanatory or the percentage of variance, if it is greater than 50, then what will happen? Then that is questionable, because the contribution of the first component or the first factor, if it is very high, that means the distribution problem is there. But if you apply the Verimax method, then you will not encounter this type of problem. Otherwise, many reviewers, they will raise this question. Why only the first factor is explaining 50%? So your first factor is very good. Another factors are not needed, right? So it is not very good if all the variables are coming under first factor. That's why rotation is applied. That's why rotation is used. And a particular method, that is the Verimax, is used in order to avoid this problem, or in order to avoid the cross-loading problem. Suppose one variable is coming under first factor and the same variable is also coming under the second factor. Then how will you take the decision where the variable will be clubbed, whether it will be under first factor or whether it will be under second factor? In order to avoid the cross-loading difficulty, that's why Verimax method, if you use, then you can also avoid this type of problem. So from the rotated component matrix, these are the variables under first factor, 3 variables under second factor. So 5 variables under first factor, second variables under second factor, and third variables, and the variables question number 12 and 9. These variables are coming under third factor. So from this exploratory analysis, we will report the result of the rotated component matrix. So these 5 variables are forming the first factor, these 3 variables are forming the second factor, and these 2 variables are forming the third factor. Now, exploratory analysis on the basis of the characteristics of these variables, the researcher is supposed to give a new nomenclature. On the basis of the characteristics of these variables, you have to give a proper nomenclature so that it will be easier for the organization to formulate their strategy. Suppose these are the 5 variables. On the basis of these 5 variables, suppose you are calling that dispute settlement or complaint settlement or the pricing or the advertising or the satisfaction. In this way, if you give the nomenclature, then it will be easier for the organization to build the strategy accordingly. So obviously the organization is also expecting. So whatever the research you are doing, it must have certain social contribution. Otherwise, why the funding agency will show their interest to raise or to disperse the quantum of funds, use quantum of funds to you? So obviously social relevance should be there. So this is called the rotated component matrix. Now, another thing I want to show you, this is also very, very interesting. How
Excuse me, sir, I have a doubt.
Yes.
Sir, in this rotated component matrix, what do these numbers represent? Are these the correlations? The decimal numbers?
Repeat this.
So in the rotated component matrix, the decimal numbers that are there, do they?
Okay. I understood. So all these variables, basically these are called the factor loading. That means in a very simple way, we can say that the standard form of covariance, that means the correlation between one particular variable and the factor. Clear?
Okay, sir. Thank you. Yes, sir. Understood. Thank you.
Madam?
Yes, sir. Yes, sir. Understood. Thank you.
Now I will show you another interesting thing, how the result of the factor analysis, exploratory factor analysis, we can use into a regression analysis. So it will be a good paper if you take the result of the exploratory factor analysis and after that you are running regression. That is another way. But most of the researchers, what they do after making the exploratory factor analysis, they go for confirmatory factor analysis. Suppose I am saying these are the 3 factors. One is F1, F2, and F3. Now the question is there any correlation between factor 1 and factor 2 and factor 3? So we have to prove it. There is no correlation among the factor 1, factor 2, and factor 3. And if you prove it, that you can also prove with the help of correlation. If you make a correlation, among the factor. And if you say there is a very negligible, you cannot say that, sir, correlation coefficient among the factors, it will be 0. No, never it will come until and unless you manipulate your data. But you can say that, sir, there is a very negligible correlation that is arising among the construct, among the factor. So from this very negligible correlation, that's why you can say that these three factors are distinct from each other. That means there is no interconnection. That is called basically discriminant validity that we check through confirmatory factor analysis. Basically, I'm just giving you the understanding, the basic and the fundamental understanding. So what is basically the discriminant? Many researchers are saying, sir, discriminant validity, AV, construct reliability, all are 0.7, 0.50, greater than 0.0. That's why discriminant validity is proved. But if I ask, what is your basic understanding about discriminant validity? I know how to compute this result. But what is the significance? What is the interpretation? Interpretation is more important rather than the computation. Computation, all the computations will be done by your software. Nowadays, so many sophisticated softwares have come in the market. The basic thing is your understanding, your interpretations. So basically, discriminant validity means all the factors are basically distinct from each other. Now, another thing, the madam, you have already pointed out, another thing, that is the convergent validity. So there are mainly two types of validity we have to check. Other validity is also there. Content validity is there, phase validity is there, nomological validity is there. So many indices part are there. I'm not discussing all these things. But the question is whether whatever the variables have come out, question number 4, that means variable 4, variable 11, variable 6, variable 10, variable 15, how you are sure all these variables belonging to this factor? That you have to also prove. So how you will prove? If there is a moderate degree of correlation or high degree of correlation among these 5 variables, then you can easily say that yes, sir, there is a moderate or high degree of correlation coefficient are being observed. So obviously these variables is under or belonging to this factor. That we can see. So I am just showing you another interesting thing, how the regression analysis will be done on the basis of the factor analysis result. So when we run this factor analysis into a main data set, whatever the data we have used, there will be certain changes. Just to observe this change. Just to observe this change.
Sir,
Yes.
Sir, you said 2 validity we must check. So one is discriminant validity and second one?
Convergent.
Okay. Yes, sir.
But I'm not saying 2 validity, madam. 2 validity, these are the very important checking. But apart from this, you have to also check the content validity, phase validity, nomological validity, right?
Yes, yes.
All these things, when you will writing a research paper or when you will write the thesis, then obviously you have to explain in a very detailed way. Not only, but these are the 2 basic checkings, right? So just again same problem. One second. Yes. What you are observing. Basically, these are the new data points that have been created through this software. I have not created it. Factor 1, then factor 2, then factor 3. Now, what I'm trying to show you. Suppose factor 1, when we will run the regression analysis, then regression analysis or multiple regression analysis, what is this? This is a basically dependence technique. Initially, I have already told you, the analysis technique is of 2 types. One is interdependence, where we are only considering the independent variables. But in case of the dependence technique, we are considering both dependent as well as independent. So suppose factor 1 score, whatever the score have been formed, the factor 1 score, suppose this is the dependent. Suppose this is the dependent. So it depends upon some variables. So that variables we have already explored. That variables we have already explored. That variables we have already explored. Suppose I am showing one result. Suppose factor 1. Factor 1, we will consider 4, 11, 6, 10, and 15. Suppose these 5 variables are my independent variables. Suppose. And the factor is the dependent parameter. So there must be some sort of correlation between these 5 variables and the factor score, that is the factor 1 score. So I'm just showing you the regression, then you just observe what is happening here. It is a trial and error method. Everything you have to check. You will get various types of results. So go to analyze. Then for running regression, we are clicking this sign regression. Then assuming there is a linear relation, go to linear. Now dependent parameter, I will take the result of factor 1. This is the result of factor 1, factor score 1. I am just dropping it to the dependent box. And independent, that means under this factor, whatever the variables have been clubbed, these are variable 4, 6,
11.
No, 7, 10. 10 under first factor. 11,
4, 11, 6, 10.
6, 10, 11. Another is 15. Another is 15.
Yes, sir.
Another is 15. I'm not checking anything. I'm just running simple multiple regression. I'm not checking all these collinearity diagnostics and all these things. Only for your curiosity, I'm showing how the regression will be done on the basis of the result of exploratory analysis. Okay. Now see. This is the regression. This is the regression result. Now check the coefficients of 5 independent variables. That must be significant. So question number 4, that is variable 4, variable 6, variable 10, variable 11, and variable 15. Now you check whether these are the significant. Question number 4, the t value is 12.76, and yes, the value is significant. That means this regression coefficient is significant. The second one, that is the 6, that is significant. Because all these variables, whether all these variables are under factor 1 or not, if these values are not significant, then we cannot say that all these variables have been properly clubbed under factor 1. In the same way, you can do the factor 2. Suppose you are analyze regression, then linear.
Sir, I have a doubt, sir. Dependent variable is a metric and independent variable which type, sir?
Excuse
dependent
me,
variable
please
is a
repeat.
a dependent variable is metric variable, sir. But independent variable which type, sir? 5-point or 10-point scale?
No, basically we have taken the score between 1 to 10, assuming this is ratio scale. We are not saying that 1, 2, 3, 4, 5. We are not saying in this way. You just observe the score 4.20, 5.70, right?
Okay, sir. Okay. Thanks.
I'm not saying it is like at 5 point or like at 7 point. Achha. Suppose we are taking factor 4 of second factor, right? This is our dependent, and we are dropping this. One second. Then
715.
huh? Where is my result? Where is my result? Rotated component matrix. Yes, rotated component matrix. Question number 7.
715, sir. 715.
Right, madam. 715. One sound is coming from your system. One, 5, and 7. Yes. Now you observe here all the variables, regression coefficients of all these 3 independent variables. These are also coming. Right. Another thing you can do. Please. Yes. Say in English.
Sorry to interrupt you, sir. I request to the participant, kindly please mute if you have no question. I humble request once again, kindly mute yourself. So please go ahead. So kindly please go ahead.
Okay. So another thing, suppose apart from this 10 independent variables, you have identified one dependent parameter. Then you can also include in this study. So in this way, the exploratory analysis, from exploratory factor analysis, we can also go to the regression analysis. So if time permits me, in any other day, if the university organizes this type of program, then I will show you the confirmatory factor analysis. That is a very, very interesting thing that is called also the measurement model. And after that, under dependence technique, the structural equation model, then the entire thing will be completed, right? So this is only the basic part, that is the exploratory factor analysis. But exploratory factor analysis, it is the more important rather than the confirmatory factor analysis of structural equation modeling. Why? The question is why? Because you are not going through the review of literature, or you are not going through the established theory. You are going to explore some new area, new dimension. But when you are making structural equation modeling, that means already there are certain established theory. And on the basis of the certain established theory, we make structural equation modeling. But in case of the exploratory factor analysis, there is no such established theory. That's why it is required, when you are running exploratory factor analysis, then you must conduct the confirmatory factor analysis. Otherwise, the total process will not be completed. But some researcher, that's why I am showing it. Some researcher, what they do, they basically transform from factor analysis to regression analysis, avoiding the part of confirmatory factor analysis as well as the structural equation modeling. In this way, research work, basically the exploratory factor analysis is done. And another thing, just I want to tell you, because it is a very good platform. In the year 2018, I have written a book on research methodology in social science, and it has been published by Sage International Publications. You may also go through this book. The detailing is there on factor analysis, exploratory factor analysis, confirmatory factor analysis, and structural equation modeling. So now I will take some questions from the participants. From my end, the session is over. So
Sir, please name the book.
Yes, one second, madam. I'm coming to the, because it is not very comfortable for me, right? Zoom platform. I don't know. So how I will stop my sharing?
Sir, I'm doing it. Don't worry.
Okay, okay. Yes. Thank you.
Thank you, sir, for your brilliant deliberation, sir.
Thank you very much, Debasish. You are very close to my heart. But
and it is not my version, sir. It is evident from the actual end user. See the participants are telling.
But one thing, I want to visit your university physically, because online interaction, it is not the perfect interaction.
Sure, sir. Sure. You are always invited, sir.
Hey, thank you. Okay, madam, name of my book is Research Methodology in Social Science.
Yes, sir. Thank you.
Stage publication. You may search into Google. No problem.
Some questions are coming in chat box.
Debasish, yes, okay. Check box.
Should I read it for you?
Yes. Yeah. That will be beneficial. Okay.
Pragnadipta asks, sir, if we find some factors from literature and then test them using exploratory factor analysis, whether those factors from literature support our study or not, is it the correct method or not?
Yes. Very good question. Whenever we are doing any study, some sort of review of literature evidence is required. Suppose you are doing exploratory factor analysis, but certain factors, it must be there into the review of literature. Otherwise, from where you have got this idea? So that's why review of literature support must be there, whether the study is exploratory, whether the study is confirmatory. This is the answer. Second question.
Any other questions, please put in chat box, or you can unmute and ask.
Yes, unmute and ask. It's a free interaction forum. No problem. Only we are sharing the information. We are not sharing the knowledge.
Sir, I have a doubt, sir.
Yes. Madam.
In exploratory factor analysis, like some of the items, they will, which are having similar characteristics, they will clump into one factor.
Yes.
Sir, is there any chances that out of those factors, there may be some independent factors, some may be dependent factor? Like based on the review of literature, we can take some independent factor and dependent factor also.
Yes, madam. Initially, your question is very, very pertinent question. When you are running exploratory analysis, you have to assume all these are the independent. But from the theory or from the review of literature, you know that there are certain dependency connection between independent and dependent. That's why you have to go for structure equational modeling. Understood my point?
Sir, that means, sir, like whatever factors we get out of factor analysis, that should be considered as independent variable.
Exactly.
Okay, sir.
Suppose, madam, again I am explaining. Suppose there are 5 factors you have explored. Now from the review of literature, you have come to know that out of these 5 factors, suppose 3 are independent in nature and 2 are dependent in nature. So you can think for structural equation modeling. Another thing, confirmatory factor analysis, it is not structural equation modeling. Confirmatory factor analysis, it is confirming your exploratory factor. But when you are running the structural equation modeling, that means some review of literature is there, some established theory is there, and you know that there are certain interconnection, then you can those factors, some of them are dependent and some of them are independent, and you are trying to make the relation among the constructs through the structural equation modeling, and in that case you have to check the path coefficient. That means that's why this is called the structural model. So one part is the measurement model, another part is the structural model. Measurement model will not say anything about the relationships among the construct or among the factor, but structural equation modeling will ensure you, is there any dependence relations among the factors or not. That's why you have to test the hypothesis. But in case of the measurement model or in case of the exploratory factor analysis, there is no question of testing any hypothesis because you are not connecting anything. But in case of the structural equation modeling, you are connecting independent versus dependent. So you have to make your hypothesis. Suppose one hypothesis, there is no relation between attitude and purchase intention. So this is your one hypothesis. So that you have to test. From where? Using structural equation modeling from the path coefficient analysis. That is the basic difference between exploratory as well as the confirmatory in one side, in one continuum, and another continuum dependence technique, that is the structural equation modeling. Understood, madam?
Yes, sir. Sir, I have another query, sir. When I was running factor analysis, sir, I clicked that option KMO and Bartlett's test, sir.
Yes.
But it was not showing the results, sir. What mistake I would have done, sir?
I have to check your data set. Otherwise, I cannot say why the KO and this is not coming.
Yeah, that table was not showing the table, sir. Though
there might be so many problems, madam. There might be so many problems. There might be multicollinearity problem. There might be inadequacy of sample size. So many problems might be there.
Oh, okay, sir. Okay.
Yeah.
Sir, one very interesting question came in the chat box.
Yes.
Suppose a person gets 8 dimensions from the literature.
Yes.
These 8 dimensions have several variables inside that. And the person need to conduct a factor analysis. Now, whether he or she should go for these 8 dimensions together or separately for each of these dimensions?
No. In this case, as you have clearly distinguished from your review of literature, there are 8 dimensions. So obviously you have to go for structural equation modeling for dependence technique.
It is being asked like whether she should run PCA for separately for the 8 dimensions or for dimensions together.
Nothing is required because you have already identified the dimension. If you are not able to identify the dimension, in that case, exploratory factor analysis, it will be appropriate for you.
Okay.
Clear?
Yes, sir. Yes, sir. Got it, sir.
Exactly.
Another question came.
Please.
Yeah. Anybody want
Sir,
to?
Sir, it's the so I cannot run PCA for all those 8 dimensions.
Madam, please.
Hello, sir. Sir, if sir, as I said that there are 8 factors, means 8 dimensions I have identified from literature.
Okay.
So can I run PCA or not? Is it the right method or not?
No. One thing. Suppose you have clearly identified 8 dimensions, right? Clearly identified, and sufficient proof is there. So why unnecessary you will run the exploratory factor analysis?
Sir, just to justify whether those factors, because those factors I have identified from different factors.
That means your question is you want to validate it, right?
Yeah. Yes, sir.
Okay.
Yes, sir.
In that case, you can do. In that case, you can do.
So, sir, I was just clarifying that can I run PCA separately for all those 8 dimensions or together I have to run?
No, madam. My suggestion is club them all together and let them fly. Now
Okay,
you
sir.
observe whether 8 dimensions have been extracted or not.
Okay, sir.
In these 8 dimensions, there might be several variables inside that. One may be
obviously.
10 variables, one may be having 5, 6, 7 like that.
Exactly.
So if the researcher want to find out, like out of that dimension, suppose there are 10 variables, whether the 10 variables retained or not, whether it is reducing, then they have to do it separately.
Exactly. Exactly.
Okay, sir. Okay, sir. I got your point. Thank you.
Yeah, Imran Hussain ji asked, sir, is there any possibility of exclusion of relatable factor which is theoretically valid?
Please repeat.
Is there any possibility of exclusion of relatable factor which is theoretically valid?
Yes, it is possible. Because whatever the thing you are doing with the help of your data set, so possibility will be there. Clear?
Any more questions?
Sir, I have one more question.
Yes.
Sir, here in Tamil Nadu, all the researchers and statisticians, they use this Likert scale, sir, for factor analysis. Sir.
Madam, I have already initially told that nowadays researchers are doing this practice, but actually it is not right. Actually,
Okay,
it is
sir.
not right. If you go through any book of software that is specifically exploratory factor analysis, any book, research methodology book, clearly mentions there one condition or eligibility criteria, that is your data must be measured using interval or ratio scale. That means the data must be metric. Clear? But your question is very pertinent. But why they are doing? Because all thing it is done by the software. Software cannot demarcate whether it is ratio or it is ordinal. Suppose like at 5-point scale, you are giving the answer either 1, either 2, either 3 or 4 or 5. So how the software will recognize whether it is the ratio data or it is the ordinal data? So they are running the factor analysis and they are getting the answer. Understood my point?
Yes, sir. You mean that we need to use either interval or ratio scale?
Exactly, exactly.
Not that ordinal, because Likert
Not the
scale
ordinal
comes under
scale.
ordinal.
Not the ordinal scale.
Okay, sir. But generally we are doing that
Generally,
only,
I
sir.
know. I have adjudicated so many theses where the factor analysis, when they have run the factor analysis, they have used exactly like at 5-point scale. Exactly like at 5-point scale.
Or sometimes 7 scales are also in literature. Yes, sir.
Exactly.
Yeah.
Any question, please?
I guess.
Is it only applicable to qualitative analysis?
Madam?
These techniques are only applicable to qualitative analysis?
No, madam. Exploratory factor analysis we are quantifying. It is a quantitative analysis.
Yes. So it will be applicable to both kind of studies. Like,
yes. But specifically we use for quantitative analysis, right?
Yes.
Okay, so wonderful session, sir.
Thank you. Thank you very much.
Sir, can you please share your email?
Email. Okay.
I'll share it in the WhatsApp group.
Sir will send you the email.
Yeah. I request.
Debasish, sir, if possible, can we have one more session, sir, if there is a possibility?
Yes, sir. We need another session from you, sir.
So let us do a separate workshop for factor analysis.
Basically,
Sir,
whatever the schedule, it has been already
sir. So not only for factor analysis, like
For
sir
structural
gave many
equation modeling.
clarifications.
Yeah.
Like we were believing like anything, but after sir explained no, like we realized that whatever we were doing, it's totally wrong.
Definitely.
Madam, I will also share. I will also share the sample data set as well as the PowerPoint presentation, right?
Yes, sir. Please do share, sir. Thank you very much, sir.
So that you can use the command step by step, and you will do in your own way.
Okay, sir. Thank you very much, sir.
I will send. Don't worry.
Pran Gopalji, please initiate.
Yes, sir. Thank you very much, sir. Debasish, sir.
So, thank you.
From my part, thank you is such a prayer that cannot be seen or touched. I must be felt by heart. I feel honored and privileged to get the opportunity to propose a vote of thanks on this special occasion. So I, Pran Gopal Pal, session coordinator of Day 4, session 8 of 2-week faculty development program on research methodology and applied econometrics and social science, convey my deep regards and hearty thanks to our honorable research person, Dr. Debasish sir, for this outstanding deliberation on factor analysis. My special thanks to convener Dr. Dibhuti sir, joint convener Dr. Shravanti Maiti ma'am, and Dr. Taraknath Sahu sir for organizing such an informative program. An event of these dimensions cannot happen overnight. The rules start ruling method in advance. We have been fortunate enough to be backed by the support of Department of Business Administration, Asa University Silchar, and dignitaries of Vidyasagar Universities. I also extended my gratitude to all backend coordinator for their continuous help and conduct the program smoothly. I also take opportunity to thank all participants without whom program would not be possible to conduct. Thanks to all for making this event successful. Thank you, sir.
Okay, thank you to all the participants as well as the coordinator as well as the announcer of this program. So thank you very much.
Thank you, sir, for giving us your precious time. And
Okay,
the
thank you.
demand calls that there should be some more sessions. So we
Okay, we'll discuss later on.
Okay, sir. Thank you, sir.
Okay,
Thank
good night.
you,
Good night.
Thank you. Good night.
And
Thank
all
you so much,
participants,
sir.
we can call it a day and we'll meet you tomorrow again at the same time, 4 p.m. Thank you. Thank you all of you.
Thank you, sir.
Thank you, sir.